This video is about conditions of convergence almost everywhere. So sufficient condition for convergence almost everywhere. Remember that this is not necessary condition and it is only a sufficient condition. So sufficient condition. The previous one for convergence in probability was necessary and sufficient. So here you recall that the definition of convergence almost everywhere or almost surely or convergence with probability 1, they are all same. We denote it with this notation. This notation means that there exists a subset of your set of your possible outcomes such that probability of A is equal 1, and for all outcomes inside A, your random your sequence of real values converges to a specific value. So it means that as n grows, the distance between these and these will shrink to 0. So this sufficient condition says that a sequence of random variable xn converges to random variable x in the sense of almost everywhere. If there exists a decreasing sequence epsilon n such that epsilon n tends to 0 when limit of n goes to infinity, such that the sum of these epsilons, remember that these epsilons, epsilon n's are non-negative, sum of these numbers is a finite number. So if this condition is satisfied, then you don't need this one. So if the sum of a series is finite, its limit should be 0 because it is non-negative. Because if this is satisfied and this is not satisfied, this sum cannot be a finite number. And also, if the distance of two successive random variable being greater than epsilon, if the sum of these guys is a finite number. So the proof of this theorem is not very hard, but the trick is that this theorem also gives you the converging point. It says that this x, the limit of x of n when n turns to infinity is equal x in the sense of almost everywhere. You can find this one by calculating this one. Remember that these guys, they tend to 0 and this sum is converging. So the theorem says that this series is a converging series that you can get it from. The proof of the theorem is not important, but the use of it can make it applicable.